This is CPM Precalculus, Chapter 1, number 69. So we're trying to write the expression in the smallest possible integer base. Okay? So we're looking at exponents. So, like, for example, let me just change the color. For example, we have 5 squared, right? We know that here 5 is the base, and 2 is the exponent. Okay, so let me look at A. Okay, A is 1 divided by 27 to the power of 5. I'm using different colors just to show you that the exponent here, let me write it in green here, right? And 5 is the base. 5 is the base. Okay, so here we have the base of 27 and 5 is the exponent. Well, what can we say is going to give us 27? Okay, so remember, we want to see, okay, so we have 1 in the numerator, 5 as the exponent here, right? 5 is the exponent. I'll even do it in green. Now this 27, can we make this base any smaller? What's the smallest integer possible? Well, let's see. When we get into squaring things, 9 times 9 is 81. 5 times 5, okay, 5 times 5 is 25. 6 times 6 is 36. So we know we can't just square something. How about taking something to the third power? Well, 3 times 3 times 3 is 27. You can put in your calculator, and we know 27 is equal to, let me use red, is equal to 3 times 3 times 3. Right? So that is equal to 1 divided by, and we know 3 times 3 times 3 is 3 cubed, right? And then we have 5 as the exponent, right? Well, here's where we can use the properties of exponents, and we'll see that 1 is divided by 3, and then because we're going to have the parentheses here, we're going to take 3 cubed to the 5th power. So this 5 goes in and gets multiplied to the 3. So it's now 3 times 5, right? And 3 times 5 is 15. So it's 3 to the 15th power in the denominator. Okay? And we know that we can put this whole denominator up in the numerator by making the exponent negative, right? So this is 3 to the negative 15th power. Okay, so that's part A. Box my answer. B. B is 1 over 8 to the x power, right? So B is 1 over 8 to the power of x. Okay, so how can we change this into a smallest base possible? Well, 1 is pretty small already. So can we make 8 any smaller, right? So we have 1 is already small. We still have x as the exponent. Well, if you notice that 8 is equal to 2 times 2 times 2, right? So it's kind of looking for patterns. And 2 times 2 times 2 is 2 cubed, right? Oops. 2 cubed. We still have to the x power. That's equal to, if we want to move, again, the denominator up to the numerator, we just make this a negative 3. So this is equal to 2 to the negative 3 to the x power. And the properties of exponents allow us to multiply x times negative 3, which is 2 to the negative 3x power. Okay, so this is the answer to B, with the smallest base possible. The base here again is 2. So we went from the base being 8 to the base being 2. Okay, so part C. C, they even tell us that this, yeah, well, I think this might be a little tricky. So we have 16 to the x power times 1 over 32 to the power of 2 minus x, right? Okay, so we have two different scenarios here going on at the same time. On the left, we have, let me move this down to more space. On the left, we have 16 to the x power, right? So what can we multiply by itself a certain number of times to get 16? Well, 16 we know, let's just write it over here. 16 could be 4 squared, right? Or what about 2? 2 times 2 is 4, times 2 is 8, times 2 is 16. So, or it's equal to 2 times 2 times 2 times 2, which is 2 to the 4th. Okay? So to make it the smallest base possible, right now it's just 16, we can go make the base 2. So let's do that. Let's say 16 is 2 to the 4th. Okay? So that's what we did with the 16, and we still have the x here. So that x stays there. We just made 16 to the 4th times, now let's do something similar, but let's keep, let's keep 2 to the power of, let's keep the power, the exponent here, 2 minus x. Let's leave it there. So this 1 over 32. So let's leave the 1 in the numerator. What is 32 equal to? So getting the smallest base possible. We know it's equal to 16 times 2. And 16 is equal to 2 to the 4th. So if we multiply 2 times 2 to the 4th, we know there's an invisible 1. So that's the same as 2 to the 5th, right? It's equal to the 1 plus 4, which is 2 to the 5th power. Okay, so 32 we could replace as 2 to the 5th power. Okay, now let's do some simplifying. Here, 2 to the 4 to the x, so 2 to the 4th power to the x power. Again, here we want to multiply these exponents, so we get 2 as the base and 4x as the exponent, right? Times, now to move the denominator up, we make it 2 to the negative 5, right? And we still have 2 to the negative, 2 minus x as the exponent that this expression is getting to the power of. Okay, so we still have 2 to the 4x. And then let's simplify this. This is going to be times 2. And again, we multiply, so it's going to be negative 5 times 2 minus x. Okay? So this one again is 2 to the 4x times 2, and let's distribute this 5 into both terms, so it's going to be negative 10 plus 5x in the exponent. Okay? And now that we have 2 to a power times 2 to a different power, we can just combine these powers by adding them because we have the same base. So this is going to be 2 to the power of 4x plus negative 10 plus 5x. Okay, so we're just adding this and this. Okay, and that's equal to, let's combine like terms. So we have 2 to the power of, okay, so 4x plus 5x is 9x plus negative 10. So 9x minus 10. So this is 2 to the power of 9x minus 10. And let's box our answer. And this ends CPM Precalculus Chapter 1, number 69.